let's see what they want us to do. They said cos 2 theta, right, multiplied by cos 30 sine 2 theta sine 30 equal to a half. So the good news with something like this is always be able to spot, you know, something that looks too good to be true. Like, for example, nothing is ever a coincidence in math. Like here, do you see that there's a 2 theta here? There's also 2 theta over there. Secondly, we have cos 30 here, and we also have cos 30 over there. You see? So this should remind you of your compound angles. Let's see here. With compound angles, we already know that there's always we always just need to look out for cases where there are angles repeating, and then you have like specific trig ratios. You see, like that's why here we have what we have, because if you check on your formula sheet, right, which is something that you want to make sure you are always with, you know, you always want to make sure that your formula sheet is always within reach, because your formula sheet is one of those things that are like super underrated, you know, because if you, for example, especially when you're working with like functions and no, with what you call with trigonometry, anytime you're working with trigonometry, that's the one time to always have your formula sheet literally always directly next to you, because with your formula sheet, it's always going to keep you reminded of what you have access to. And I'm trying to get a formula sheet here. I'm not sure where I put a formula sheet. Let me see here. Where is the formula sheet? Euclidean geometry. Let me see if I can get a formula sheet here. Nope. Warm-up exercise. Blah blah blah. I always have formula sheets everywhere, but I can't seem to get one now. Let me just. Oh wait, I can just search for it. Formula sheet, because I know I have a formula sheet somewhere. Let's see here for formula sheet. Yeah, there we go. Formula sheet. So if you check on the math formula sheet, right? Let me just open this. Let's see. It's loading. There we go. So on the formula sheet, if you see here, right? Yeah. You can easily see that. Look, there's stuff. As long as something repeats, cos and cos, sine and sine, or sine cos, cos sine, or sine cos, cos, anything that looks like this should remind you of these compound angles here. Because with these compound angles, for example, all we need to look out for is something that represents what we have. You see cos and cos with a minus in the middle, and then sine and sine. So for example here, cos and cos, and then sine and sine with a minus in the middle, it basically can be converted into just cos, the two angles being added together. So that's what we know this can be, you know, without even overthinking it. We already now know. Pardon?
I got it. Like once you mentioned compound angles, I really did it already. Like,
yeah, because now you can see this is equal to a half, and then from there we already know that we would be able to do. I think from here, the one thing we need to keep in mind is that from here we need to be careful that we are going to get a reference angle that we should not use too loosely. Like for example here, we already know that our reference angle is going to be equal to shift cos with a half, and then in the calculator, shift cos with a half, this is giving us 60. Yes. And then this is just the reference angle, so that now we are able to, again, as said, the sign here should tell us that we're supposed to work in the first quadrant and the fourth quadrant. So in the first quadrant, it's just a matter of carrying on, where you will have, let's see here, 2 theta plus 30, right? You know that it's going to be equal to your reference angle there, and then plus k 360, k is an element of integers. The reason you want to put this as soon as possible is because now when you're working this out, right, you're going to have here 2 theta, right, equal to 60 minus 30. Yeah. And then the plus k 360 can just be lingering there. Because now when you see you have to divide by 2, you need to remember that you divide everything by 2. You see, meaning here you'll have theta, here you'll have 30, right? But then divided by 2, that's like a 15. And then here you know that you have plus k 180, and then k is an element of integer, so that you don't forget to also divide the part where it says k. And then for the fourth quadrant, we know that we would just have the 2 theta plus 30 is equal to 360 minus our reference angle plus k 360. K is an element of integers. And then here, we know that this is like 300 minus the 30. You see, this is going to be 300, and then when the 30 goes over, we will subtract it. So this is just going to be 270. And then we know that here, if you divide everything by 2, we are going to have here 135 plus k180, k180, k is an element of integers, and then this is just theta. You see?
Yeah.
Perfect. So I think the one thing you can take away from this question was pattern recognition. The more examples you're going to go through, you're eventually going to bump into certain things where you will start to bump into them again. And then your brain will now be able to like store the information to say that, okay, wait a minute, certain things like this, they repeat, they ask questions like this. Because the good news is, if you saw also, you said the moment I mentioned compound angles, it sort of like clicked in your head that, oh, wait a minute, it's done now, you know, because from there you were able to then now just refer to other knowledge, other pieces of knowledge that you have in your head.
Yes, yes.
Perfect. Anyways, so let me just stop this one here, and then on the in terms of the sleep schedule, right?